Okay, so we're going to use our combinations permutations to solve a little bit more complex probability. You'll want to make sure you've seen the video on permutations combinations before you do this one. So otherwise this one won't make too much sense here. So all of our complex probabilities, we're going to have three different, and the reason why they're complex is because we're going to be using those combinations in our probabilities to find the number of total and the number of ones that we're interested in. Again, probability is always, again, just as a quick reminder, it's always going to be the number of interest, like that we're interested in the number of total. And so our combinations, permutations will help us with this. There are three basic questions that are going to have words like exactly. For example, this one has exactly 5 girls here, right? At least or at most are the same idea. And then when we have two options, so something like a true false question, or whether somebody's whether we have a boy or a girl. So anything that has like a two option falls under this type. Okay, so I'm going to walk you through how to solve these, and we'll go from there. We're going to be using our combinations and permutations. So, and then just come back, and if you need to look at these, that's a good. These are good reference points. These ones here. So let's say, for example, let's start with the left one exactly. Let's say I've got a class with 6 boys and 10 girls, and if we're, as a teacher, we're going to randomly select 7 students. Again, I do not care about order, so this is all going to be combinations. What's the probability that he picks exactly 5 girls? So again, I'm going to have my fraction here, and I want my denominator is going to be the total number of ways of picking 7 students from the total here, which there are 16 total students, 6 and 10. So I want to know how I can pick 7 from 16. To do that, I would do 16 combinations of 7. That's what I would do in my calculator for that one right there. And the top one's a little bit more complicated. So I need exactly 5 girls. So from the 10 girls, I need to pick 5. And then the other 2 to make up the 7 need to come from the boys. So again, from the 10 girls, I need to pick 5. So that would be 10 combinations of 5. Okay. And then I need to pick 2 boys from this 6. So that would be 6 combinations of 2. And then I'm going to multiply this together because I need these two things to happen at the same time. This is a lot like our multiplication. I need this to happen and then that to happen for that to occur. Okay. And then I just use my calculator like we did the other day for this one. So when I take my numerator and I times those two together, I get 3,780. And if you're having calculator errors, come talk to me. And then the denominator is going to be 11,440. And when I actually get when I go to get my percentage, again, this is a percentage, I have 33.04%. This gives me like 0.3304, which should be 33.04%. And that's what I'd be looking for on that one. So exactly, I always put my total, and then the top is going to be usually two things that are multiplied together. I've got to take into account the different options that I have. I have boys, girls, so I'm going to go that route and I multiply them. Okay, the at least or at most is similar, just a little bit of different because I have to take into different accounts here. So I'm going to look at this one. This is fireworks that are being launched. I have 9 total fireworks. Again, 5 of them blue and 4 of them red. I'm going to launch 5 of them in a random order. What's the probability? At most 3 of them are blue. So I'm going to see how many number of ways I can fire 5 from 9 first. That's going to be my denominator. Okay, so my denominator is going to be this 9 combinations of 5 because that's the total ways regardless of blue, red. I just want to choose 5 from 9. My numerator gets a little bit more complicated. So at most 3 are blue. So let's say I had exactly, so let's go back to this exactly one, exactly 3. Okay, if it was at exactly 3 that were blue, so then I'd have to go to the 5 blues and choose 3 of them. So that would be 5 combinations of 3. But then the other 2 to make up the 5 that I'm launching have to be red. So that would be 4 combinations of 2, and I'd multiply those. That would be exactly 3 blues and 2 reds is what that would be. Okay, and that fits into this at most. Okay, but that's not the only way that we could do that. We could also say we had, let's say we did 2, because 2 blues fits in as this at most 3. So if I did 2 blues, that would be 5 combinations of 2. And if there were 2 blues, that means I have to have 3 reds. So that would be 4 reds that I'm going to choose 3 from, and I'd multiply those together as well. And then there's one more. I could actually take 1 blue as well. So I could go 5 combinations of 1. That'd be 1 blue. And then I would do 4 combinations of 4, which I'd need all 4 of them to be red at that point in time. And then all I do is just add all these individual things together. The reason why I don't go 5 combinations of 0 and then 4 combinations of 5, I can't do that because there's only 4 reds. So that means one of them has to be a blue if I'm going to launch 5 of them off. So these are my only 3 options. I can have 3 blues, 2 reds. I can have 2 blues, 3 reds, or I could have 1 blue and 4 reds. And so I have to account for all of those and then multiply them. And then that's my total over there, okay? When I do that, I get 105 in the top. I think this gives you 60. This gives you 40, and that gives you 5. And then my denominator is going to be 126 with that one. And then the last thing I do is just get this as a percentage. I think you get 0.833 repeating, which would be 83.3%, 33% chance of that occurring. So that's the at least or at most. So if it's at least, then instead of going down like I went 3, 2, 1, I would go up instead until I get to the options that I can't anymore. Okay. These ones are not necessarily, I'd say difficult, but it's just there's just more to it. And sometimes we relate more as being difficult. It's just, but if you understand the idea, it's actually not too difficult that way. Okay, the last one is when we have 2 options. So this one, we've got a 11 question true-false test. And let's say a student totally forgot study and is just going to randomly guess because none of us have done that before. And so we're going to look at this. What's the probability the student answered exactly 9 of those questions correct? So my denominator, again, my denominator is always the consistent part. I want exactly 9, so I'm still going to go 9 from the 11. So I'd go a net 11 combinations of 9. Again, order does not matter. I've got to choose 9 of the 11 to be correct. Okay. My numerator, oh shoot, I apologize. Sorry, my bad. So hold on a second. Sorry, that would actually give me the number of ways of getting 9 right and then the other one's wrong. So hold the phone for just a minute on that one. I've got that actually is my numerator. So 11 combinations of 9 would be my numerator, and then I could times it to the number that would be wrong. But if it's just one option or the other, that means this is the only way to choose those combinations because the other ones have to be wrong. So I don't have to take into account all these other situations here. So it's just 11 combinations of 9. My denominator is the one that changes. Okay, my denominator is no longer just a combination. What it is, if I only have 2 choices, I'm going to go 2, and this stays consistent to however many however many questions there are in this case. So this would be 2 to the 11th is what it is. If I was doing a 20 question test, then I'd go 2 to the 20th. If I had a 15, it'd be 2 to the 15th, so on and so forth. Okay. When I calculate these ones, I end up getting 55 over 2,000 and then 48. And this gives me approximately like a 2.69% chance of that occurring. So, okay, so those are your 3 different ways there. This has been your Math Moment with Mummy. Goodbye.